So today, by popular demand, I'm going to go over these metric conversions for you. Um, a lot of people seem to be having problems with this when they get into chemistry, either fundamentals of chemistry or chemistry 1. And so I wanted to go over what you need to know and how to do the conversions knowing these numbers like this. So as you can see, we have the prefix is what goes at the beginning of the word, like centimeter, kilometer. So we have like kilo right here. We have centi down here. Here's millimeter. So these are the prefixes that you put in front of the unit of measurement, like meter or gram or liter or something. So you can have a kiloliter, a kilogram, a kilometer. You can have a centimeter, a centigram, a centiliter. You can have a milliliter, and so on. So these are going to be the prefixes in this column. And here's their abbreviations. So as you can see, these top really large ones, the Giga and the Mega, they're capital G and capital M. And the rest of these are going to be lowercase, from kilo all the way down to nano. These are all lowercase. So the only capital ones are the two big ones up here, Mega and Giga. Now let's explain what all of these numbers mean. This probably looks confusing, and don't worry about it. It's not as bad as it seems, but there is going to be some memorization that you're going to have to do as far as like a couple of these. Like you're probably going to have to memorize kilo, you need to memorize centi, you need to memorize milli, and you might need to memorize nano. So those are the ones that chemistry teachers tend to focus on when they have you do problems, chemistry problems in class. So first, let's just talk about the word centi, or the prefix centi. If this looks familiar to you, it should, because this is where the word cent comes from. So 1 cent, if you write it with a dollar sign, think about it in terms of dollars. 1 cent is going to be $0.01. And that's how you're going to write a cent in the dollar sign. And what does cent mean? Cent means 100. So that means that 100 cents are needed to make up just $1. So if you think of it that way, 100 cents, a cent is smaller than a dollar, and it takes 100 cents to make $1. So here's the 100 right here, and our decimal point goes after the $1 right there. Now, conversely, we have a larger prefix, and that's kilo. And kilo is big. Kilo means 1,000. Kilo, if we had kilo dollars, that would be $1,000. Because kilo is big, and there's going to be 1,000 of that something in a kilo. So if you have 1,000 meters, that equals 1 kilometer. If you have 1,000 grams, that's going to equal 1 kilogram. Now, cents, of course, if you have 100 cents, 100 centis meters, that's going to equal 1 meter. So let's look at this table again, and you can see down here is the centi, and I have it down here on the bottom because these are the small prefixes, so they're going to be smaller than 1. Just like a centi, a cent is smaller than a dollar. So centi is going to be smaller than 1. We need 100 cents to make a dollar. So we need 100 centi somethings to make 1 of whatever that something is. So we need 100 centimeters to make a meter. Up here, kilo, I have all of these on the top because these are the bigger ones. So bigger. than 1. So a kilo means 1,000. It's going to take 1,000 meters to get 1 kilometer, or 1,000 grams to get 1 kilogram. So let's go over these, and we're going to fill in the blank. We're going to have this blank chart, and we're going to fill these in like a logical format, so hopefully this will help. So first, in this white space down here, this is just going to be our base unit. This is going to be 1 of something. 1 of something. So 1 meter, 1 liter, 1 gram. So just 1 of something. And the scientific notation for just 1 of something, and if you're unfamiliar with scientific notation, then go back and watch my video on scientific notation and how the decimal place moves, and that might help you too. But the scientific notation of 1 is going to be 10 to the 0 power, because anything to the 0 power equals 1. You could have 749 to the 0 power, and that's going to equal 1. So anything to the 0 power equals 1. So this is going to be 1 times 10 to the 0 power is just 1 of something. 1 meter, 1 liter, or 1 gram. Now going up 1 up above this, getting bigger than 1 of something, we have Deca. And Deca is abbreviated DA, and Deca means 10. So a decameter means there's 10 meters. A decaliter means there's 10 liters. A decagram means 10 grams. And the scientific notation for that is going to be 1 times 10 to the 1, because 10 to the power of 1 equals 10. Right? So if we have 10 meters, we're going to have 1 decameter. Now, opposite of Deca, down here in the red, is going to be the small. We're going to have the smalls down here, and we're going to have the bigs up here. So the opposite of Deca is going to be deci. And that's just abbreviated with a regular old D. That's why Deca is abbreviated with DA. We don't want to get it confused with deci. Now a decimeter is 1/10 of something. So if you have 1 meter, you have 10 decimeters. And the scientific notation for that is going to be 1 times 10 to the negative 1. And that's going to equal 0.1. So one decimeter is 0.1 meters. Just like up here with Deca, 1 decameter is 10 meters. So you could also say with deci, this 0.1 meters, that's the same thing as 1/10 of a meter. So Deca and deci, they have to deal with 10. Our next one, going up in the bigs, is called Hecto, like Hector. And that's just a lowercase h, and that means 100 of something. So if we have a hectometer, we have 100 meters. And the scientific notation for that is going to be 1 times 10 to the 2nd power, because that equals 100. So that's going to be 100 meters if we have 1 hectometer. Now the opposite of hecto, this for the small, is going to be centi. And we already went over centi. Centi is abbreviated lowercase c. And centi means 1/100th. See, 1/100th. And the scientific notation for that is going to be 1 times 10 to the negative 2. So that's the same thing as 1/100th. meters. So if we have a centimeter, we're going to have 1/100th of a meter. So 100 centimeters will make up 1 meter. Now going back up to the big section, our next one is kilo. So kilometers or kilometers, and that's lowercase k, and kilo means 1,000. So if we have a kilometer, we have 1,000 meters. And the scientific notation for that is going to be 1 times 10 to the third, because there's 1, 2, 3 zeros after the 1. So that makes up the third. 1, 2, 3. So that's 10 to the third. So if we have 1 kilometer, we're going to have 1,000 meters. Now the opposite of kilometer, down here in the smalls, is going to be milli. And that's a lowercase m. And milli is 1/1000th. So it's 1/1000th. Because see, up here in the bigs, this is going to be just 10 of something, of Deca. Deci is going to be 1/10. Hecto is going to be 100 of something. Centi is going to be 1/100th of something. Kilo is going to be 1,000 of something, and milli is going to be 1/1000th of something. So that means it's going to take 1,000 milligrams or 1,000 millimeters to make up 1 meter. And that is written in scientific notation 10 to the negative third. Because 1 0, decimal point, 2 zeros, 3 zeros, and then a 1. Now back up to the big again. Now we have mega. And mega is capital M. And mega means 1 million. One million of something. Mega million. So if you have a megameter, you have 1,000,000 meters. And that scientific notation, we were doing 10 to the 1, 10 to the 2, 10 to the 3, but now we're going to jump up and say 10 to the 6th. Because see, if you notice on 1,000,000, there's 6 zeros after that 1. There's 1, 2, 3, 4, 5, 6. So that means we're going to have 10 to the 6th. Now the small version of that, of mega, is going to be micro. And micro is abbreviated with this funky looking U. It's got a little tail on the front side of it. Funky looking U is micro. And micro also means 1,000,000, but it's 1/1,000,000th of something. So that's going to be written 0.000001. So that is going to be in scientific notation, that is going to be 10 to the negative 6th. So it's going to take 1,000,000 micrometers to make 1 meter, or 1,000,000 micrograms to make 1 gram. Now the last one, we'll go back up to the top and do the big one, is giga. And you've probably heard the term giga before, gigabytes, like in your computer, and that's capital G. And giga means 1 billion. So 1 giga means 1 billion. So this is going to be written as 1 times 10 to the 9th. Because look, we have 9 zeros after this 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 10 to the 9th. Now the opposite of giga, where it's going to be 1 billionth, is going to be nano. So nanograms, nanometers, and that's just a little lowercase n. And that's going to be That's going to be 9 zeros, including the decimal point, and then a 1 after it. So that's 1 billionth. And that is going to be written 1 times 10 to the negative 9th. So see, these are all equally, they're all the opposites of each other. So this nano down here is going to be 10 to the negative 9th, which is the opposite of this giga up here, which is 10 to the 9th. So this giga means there's a billion meters if you have a gigameter. This nano, if you have a nanometer, it's a billionth of a meter. So hopefully that's going to make more sense to you. And this down here is going to be your baseline. This is just a meter, a gram, or a liter, something like that. So if you put one of these prefixes in front of it, like a decameter, a hectometer, a kilometer, a megameter, a gigameter, then that's going to be 10 grams, or 10 meters, or 100 meters, or 1,000 meters, or a million meters, or a billion meters. Down here, if you have a decimeter, or a centimeter, or a millimeter, or a micrometer, or a nanometer, that's going to be smaller than a meter. So it's only going to be 0.1 of a meter, or 0.01 of a meter, or 0.001 of a meter. So I hope that makes sense. Let's try some conversion factors and see if this makes better sense to you. Now we have as an example problem, if your bed is 376 centimeters long, how many meters long is it? Well, first I look for the how many or the how much, whatever the question is trying to ask. So here's this how many meters. So here's the question that the word problem is trying to ask. How many meters? Question mark meters. And the numbers that we have been given in this is if your bed is 376 centimeters long. So I'm going to set that equal to the question mark meters. So how many meters equals 376 centimeters? So we have that written out with set in as an equal sign to something else. So we have our question mark, and we have that set equal to the 376 centimeters. Now we have to remember the conversion factors for centimeters and meters. And remember, as I was saying, a cent, 1 cent, 1 penny, 100 cents make $1. So likewise, 100 centimeters is going to make 1 meter. So now that we have this information, we can go ahead and set up our problem and just do the math. And we always start with the question mark row, and we hop over to what we know, which is the 376 centimeters. So we're going to write that down, 376 centimeters, and we're just going to put it over 1. And then we're going to write down another multiply sign and a fraction bar. Now look at this fraction we just wrote, this 376 centimeters over 1. We look at the top of the fraction and its unit of measurement, which in this case it's centimeters. And we bring the centimeters down to the bottom of this next fraction bar. And then we're going to look up at our data table, and we're going to look for where else it mentions centimeters, which is right over here, 100 centimeters. So we're going to write in that 100 centimeters. And whatever is on the other side of the equal sign, this 1 meter, we're going to write on the top of the fraction, 1 meter. Now we can go through and we can cancel out any units of measurement that appear on both the top and the bottom of the fraction bars, because if they're diagonally across from each other, then they cancel each other out. So we have a centimeters up here and a centimeters down there, so they cancel each other out, leaving us with this just lonely meter right here. Now let's look back up at our question mark. And is that what it's asking? The question mark meters? Yes, it is. So we know we've set this up correctly because this unit of measurement that's left should be the same unit of measurement in our question mark up in the data table. So now we can just go ahead and multiply across. We have 376 times 1 meter over 1 times 100. So that means 376 meters over 100. And if you take your calculator and you divide 376 by 100, you're going to end up getting 3.76 meters. So if your bed is 376 centimeters long, it's going to be 3.76 meters long. So this one is a little bit more complex. It's going to require an extra step, but don't worry, we're just going to do this the exact same way we did the other ones, so you can get used to it. How many milligrams is in 3 kilograms of laundry detergent? So first, the first thing I told you to do is look for the how many or how much in the question. That's what they're asking. And they're asking how many what? How many milligrams? So we're going to put question mark milligrams. How many milligrams? And then we'll look for the equivalency is in 3 kilograms of laundry detergent. So we're going to make that an equals to 3 kilograms. Now we need to remember the conversion formulas for milli and kilo. And if you remember, let's go back to the table. On kilo, this kilogram means 1,000 grams because kilo is big. So 1 kilogram is 1,000 grams. So let's put that on our table. 1 kilogram equals 1,000 grams. Okay, now what about milligrams? Let's look at our table. And milligrams is down here in the smalls. So 0.001 milligrams is in 1 gram. Or you could also say 1/1000th, or 1,000 milligrams is in 1 gram. So let's write that down on our table. 1,000 milligrams is in 1 gram. Alright, so now we have our conversions, so we can write this out like usual and just go ahead and solve it using multiplication. So of course we always start with the row that has the question mark in it, and we go for what we know. We know 3 kilograms is in this row, so we're going to write down 3 kilograms, and we're just going to put that over 1. And we're going to write a multiply sign and another fraction bar. And now we're going to look at this fraction we just wrote, 3 kilograms over 1, and we're going to notice that the unit of measurement is kilograms. So we're just going to bring that on down to the next fraction bar and put kilograms down here. And we're going to look up at our table and find another place where it mentions kilograms, which is right here, 1 kilogram. So we're going to write 1 kilogram, and whatever is on the opposite side of the equal sign up here, 1,000 grams, we're going to put on the top of the fraction bar, 1,000 grams. Then we're going to write another multiplication sign and another fraction bar. And we're going to look at our last fraction we just wrote, 1,000 grams over 1 kilogram, and you just look at the top number, and that top number's unit of measurement is grams. So we're going to bring that on down to the bottom of this next fraction, and put grams there. And we're going to look up at our data table for where it mentions grams, which is right here, 1 gram. So we're going to write 1 gram, and then whatever is on the other side of the equals sign, this 1,000 milligrams, we're going to write up here, 1,000 milligrams. Now we can go through and we can cross off any of the units of measurement that appear on the top and the bottom of the fractions. So we have kilograms here, and diagonally across from that is kilograms. We can cross those out. We have grams here, and diagonally across from that we have grams, so we can cross those out, leaving us with just one lonely milligram unit of measurement. Now let's go back up and check our question mark. Is that what our question mark is asking? Question mark milligrams. So yes, so we know we set it up right, because our unit of measurement left is the unit of measurement we need for our question mark. So now all we have to do is multiply across. We have 3 times 1,000 times 1,000 all over 1 times 1 times 1. So 3 times 1,000, this is going to be 3,000, and 3,000 times 1,000 is going to be 3 million. So, and don't forget your milligrams, so we're going to have 3 million milligrams, which is going to equal 3 kilograms.